OWASP, Open Web Application Security Project, is a well-known organization that focuses on improving the security of software. While OWASP is primarily known for its work on web application security, many of the principles and vulnerabilities it identifies are also relevant to Kubernetes application deployments. Following is a detailed view of how OWASP-related attacks can manifest in Kubernetes environments. 1. Injection attacks. Description: Injection attacks occur when an attacker sends malicious data to an application, which is then executed as part of a command or query. In Kubernetes, this can happen through misconfigured containers, APIs, or workloads. Kubernetes-specific risks. Exploiting misconfigured kubectl commands or API calls. Injecting malicious YAML files or Helm charts into the deployment pipeline. Exploiting vulnerable containerized applications. Example, SQL injection in a pod. Mitigation. Validate and sanitize all inputs to Kubernetes manifests and Helm charts. Use admission controllers like OPA Gatekeeper or Kyverno to enforce policies. Regularly scan container images for vulnerabilities. 2. Broken authentication. Description: Weak authentication mechanisms can allow attackers to compromise credentials, keys, or tokens. Kubernetes-specific risks. Weak or default credentials for Kubernetes applications. Misconfigured role-based access control policies. Exposed service accounts with excessive permissions. Mitigation. Enforce strong authentication mechanisms, example, multi-factor authentication. Use role-based access control to limit access to Kubernetes resources. Regularly rotate service account tokens and secrets. 3. Sensitive data exposure. Description: Sensitive data such as secrets, tokens, or credentials can be exposed if not properly protected. Kubernetes-specific risks. Storing secrets in plaintext in Kubernetes manifests or environment variables. Exposing secrets through misconfigured ECT, Kubernetes key value store. Leaking sensitive data through logs or debugging endpoints. Mitigation. Use Kubernetes secrets to manage sensitive data securely. Encrypt secrets at rest, example, enable encryption for ECT. Avoid logging sensitive information and use tools like Falco to monitor for data leaks. 4. XML external entities, XXE. Description: XXE attacks exploit vulnerabilities in XML processors to access sensitive data or execute remote requests. Kubernetes-specific risks. Vulnerable applications running in pods that process XML inputs. Exploiting misconfigured API servers or admission controllers. Mitigation. Disable external entity processing in XML parsers. Use secure configurations for Kubernetes API servers and admission controllers. 5. Broken access control. Description: Improperly configured access controls can allow unauthorized users to access resources. Kubernetes-specific risks. Misconfigured role-based access control policies granting excessive permissions. Exploiting overly permissive network policies or pod security policies. Mitigation. Follow the principle of least privilege when configuring role-based access control. Use network policies to restrict pod-to-pod communication. Regularly audit role-based access control configurations and permissions. 6. Security misconfiguration. Description: Misconfigurations in Kubernetes deployments can lead to vulnerabilities. Kubernetes-specific risks. Exposing the Kubernetes API server to the public internet. Running containers with root privileges or unnecessary capabilities. Using default configurations for Kubernetes components. Mitigation. Harden Kubernetes clusters by following security best practices, example, CIS Kubernetes benchmark. Use tools like KubeeWALL to check for misconfigurations. Regularly update Kubernetes components and dependencies. 7. Cross-site scripting, XSS. Description: XSS attacks involve injecting malicious scripts into web applications. Kubernetes-specific risks. Vulnerable web applications running in Kubernetes pods. Exploiting misconfigured ingress controllers or load balancers. Mitigation. Sanitize and validate all user inputs in containerized applications. Use content security policies, CSP, to mitigate XSS risks. 8. Insecure deserialization. Description. Insecure deserialization can lead to remote code execution or data tampering. Kubernetes-specific risks. Vulnerable applications running in pods that deserialize untrusted data. Exploiting misconfigured API servers or admission controllers. Mitigation. Avoid deserializing untrusted data. Use secure serialization formats and libraries. 9. Using components with known vulnerabilities. Description. Using outdated or vulnerable components can expose Kubernetes deployments to attacks. Kubernetes-specific risks. Running container images with known vulnerabilities. Using outdated Kubernetes versions or dependencies. Mitigation. Regularly scan container images for vulnerabilities using tools like Trivy or Claire. Keep Kubernetes components and dependencies up to date. 10. Insufficient logging and monitoring. Description. Lack of proper logging and monitoring can make it difficult to detect and respond to attacks. Kubernetes-specific risks. Failing to monitor Kubernetes API server activity. Not logging pod or container activity. Mitigation. Implement centralized logging and monitoring using tools like Prometheus, Grafana, and ELK Stack. Use Kubernetes native tools like kubectl audit to track API server activity. Additional Kubernetes-specific threats. Container breakouts. Attackers exploit vulnerabilities in container runtimes, example, runc, containered, to escape the container and access the host system. Mitigation. Use secure container runtimes and enforce pod security policies. Misconfigured network policies. Lack of network segmentation can allow lateral movement within the cluster. Mitigation. Use Kubernetes network policies to restrict traffic between pods. Supply chain attacks. Attackers compromise container images or Helm charts in the deployment pipeline. Mitigation. Use trusted sources for container images and Helm charts, and sign/verify artifacts. Privilege escalation. Exploiting misconfigured role-based access control or pod security policies to gain elevated privileges. Mitigation. Regularly audit role-based access control configurations and enforce least privilege. By addressing these OWASP-related risks and implementing best practices, you can significantly improve the security of your Kubernetes application deployments.